자, 두 번째 초청 연사 모시겠습니다. 덴마크의 헤닝 라슨 아키텍처의 파트너시자 서스테이너블 디자인 부서의 팀장을 맡고 계십니다. 시네 콩브루스를 무대 위로 모시도록 하겠습니다. 시네 콩브루스는요, 친환경 건축 전문가로서 덴마크 정부의 혁신팀 소속으로 활동을 하고 계시고요. 그리고 덴마크의 7명의 싱크탱크 중에 한 분이시기도 하시고 덴마크에서는 굉장히 유명 인사 중에 한 분이기도 합니다. 최근에는 디자인 위드 날리지라는 주제로 책을 또 출간한 바가 있고요. 오늘 그 주제로 여러분과 같이 얘기를 나눠보고자 합니다. 여러분 큰 박수로 시네 콩브루스를 환영해 주시기 바랍니다. Please welcome her with a big hand.
Thank you, and I will continue where I started before lunch. And this lecture is called Design with Knowledge, and I'm trying to, with this lecture, to give examples of how we influence the design in the office with knowledge on especially energy performance. We are a small group in the office. 10% of the office works especially with sustainability. It's a research and development department. And what we are especially interested in is new scientific knowledge on sustainability that is applied in the early design phases. We are not so much interested in the detailed design, because then we collaborate with very good engineers. But in the early stages, we have a huge influence on the direction of the building. The group consists of both engineers and architects and graphic people and communicators in different ways. The way we do it is that we create new scientific research. We have PhDs in the office. We also do development projects like the one I showed before with the daylight renovation strategy. So we get different kind of funding from public foundation and private foundation. And then we do, for example, the book here, Design with Knowledge, or we do different kind of publications that are more, you can say, design tools and ready for everybody to understand. So it's not so scientific, but it's more a toolbox. And then we massage this kind of knowledge into the projects. Of course, you can't have it all in all projects, but we are trying. I would say 2/3 of the projects that we do has sustainability issues that are more than just the general stuff. But you have to choose your battles each time. Is it materials you're working with? Is it a comfort issue? Is it an operational issue? Is it an urban environment issue? So it can be different issues, and we try to be able to communicate very clearly what are the aims for the different projects, and they always differ. I will just start this presentation just showing a few slides of the different kind of architecture we do, just so you are informed of the company profile. This is a Calabar International Convention Center in Nigeria. We are constructing it right now. It's actually the first building in a huge master plan, so it's you can call it the Bilbao effect or the Sydney Opera effect, that you sort of put the first building in an area, and by that you generate the standard and the symbol of the coming area. This is the Spiegel headquarter in Hamburg. It has a gold medal in the Hafen City Standard, which is one of the first second generation certification systems in the world. And then the HAPA I showed before as well. It's a very big and very interesting building where we work together with a famous artist called Olafur Eliasson, and we work together with him on the facade and try to use the facade in different ways to filter the light. And this is the Crystal Towers in Saudi Arabia. It's actually part of the same master plan, the King Abdullah Financial District. The master plan consists of 150 buildings, and we are doing 5 of them, sort of following our own design manual. And you will see here that it's actually very covered. It's not on some of the orientations. It only has this kind of opening, and towards other orientation, it's more open. You can say that sustainability is many things, and I think that for me, sustainability equals development. It's never a static thing. What is sustainability for the future 2 years ago is different from now. So the whole discussion and the development of sustainability is part of the essence of doing it. Right now you can say that we have a huge focus on energy performance because of the CO2 emission on the ICCP. It's actually the number one challenge we have right now, driving the huge climate change, as Sue spoke about earlier today. And this presentation, I will give you some examples of how we work with energy performance in buildings and how it relates to the design of the buildings. Our research shows that between 40 and 50% of the energy consumption is determined by the design. And you can say that it's 80% of the most important part of the design is done, the first month. So we have a huge influence and responsibility to do this right. I'm not talking about 0.01, I'm talking about plus minus 5. We need to go in the right direction from the beginning, and you need to sort of teach the intuition in the hand to work in this way. You can't sit and do a calculation and then do a design. You need to teach your imagination to work in this way. And it takes a long time, and it's actually a tough thing to do. What we do in the office, because we are a big office, we need to communicate internally, of course. We start the design by reducing the energy consumption. So the most sustainable energy is the one that you will never use. So we take that out of the building by organizing the geometry right in relationship to the context, come up with the right daylight concept. We place main functions in the right directions in the building, cell offices and meeting rooms and classrooms and so on. And then we lay out the overall system for the building. Is it a hybrid system? Is it a fully ventilated, natural ventilated system, or mechanical, and so on? This is something that we do anyway when we do our design, so it doesn't cost extra, you can say, for the client. It's just organizing the space right. And it's part of the concrete structure that you put in the ground anyway. Well, if you want to do a more optimized building, you need to optimize on components and installations. And this is where it becomes technology, but that's something we do afterwards. And finally, if you want to hit zero or nearly zero, you need to produce energy on the buildings. We haven't found the solution yet to do a zero energy building without renewables. But our aim is to do 40 kilowatt hours per square meter per year and not using any renewables at all, because we like to use the money where you can gain more architecture, and we have problems with the social value of, for example, of PV. I would like to show you an example that it can actually go wrong if you don't do this right. This is a gymnasium done from one of our biggest competitors in Denmark. It's a very, very beautiful building. It actually has an energy performance that is very low, and it is designed with this very beautiful atrium. It works socially, and it also works environmentally, because it completely drives the whole energy performance of this building because of the solar gain and the ventilation during summer and winter. And this is what it looks like. So you have this south facade, and the problem is that this is a part of a new urban area in Copenhagen, and suddenly they build a school 12 meters from this facade, and it's 8 floors high, and it completely blocks out everything from this original facade. And here you see some testing of different volumes, and you will see the solar radiation on the existing facade, and you will find the first sketch, and you can see that the atrium suddenly has no solar gain. And what happened is that his name here is Mr. Kim, but he is actually running the gymnasium, and the energy performance went up. He made a deal with the city hall about, for each time he saved a kilowatt hour, he would gain some money for the annual school party. But suddenly it just goes up, and he can't do anything about it. So the point here is that you can't just think of your own plot, think of your own building, doing a smart, you can say, car design. You need to think about the relationship to other buildings and the possible urban situation around you. So the robustness of the strategies that we use needs to be tested out in different settings. I will show you an example of a building that is, they haven't moved in yet, but we have almost completed it. But this is a render. It's a big pharmaceutical in Denmark. It's actually, I think it's what Samsung is for you, is Novo is for the Danish people. So it's a very important client. We started out making a cool island effect. We want to make a very humid and cold area around the building, so we would lower the energy performance for cooling with 5 degrees, just by organizing the landscape right and actually making a lot of hills and using the virgin land in a new way. This is the floor slab, and you will see that you have all the offices around along the edge, and in the interior you will have the atrium. It's actually a very deep building, and this is the section. It's a corporate headquarters, so it's actually, you will find a lot of different nationalities coming to this meeting center, and the whole management of the company is also located here. The reason why I show this is because I need to show the relationship between the design and the energy performance. At this time, in Denmark, we had a reference that you should maximum use 95 kilowatt hours per square meter per year for this kind of office building. Now it's 70, so it's getting lower and lower. So this is a reference, and here we start reducing the energy performance by making this land use in the middle of this green area. We also made a round shape, and it's not because of compactness, because our studies shows that the compact factor doesn't really mean anything, because we need to use so much insulation. So if it's 30 or 35, it's not really the issue. It's the first 5 is most important. But we made it round because at the daylight access from a round-shaped building is 17% more than with a square building. So you will have access to more sky during the day, and in that way it's very efficient for an office building. And you will see that the numbers is actually put here. And then the daylight concept, an atrium in the middle, and these big cuts also allowing an entrance from different sides. And then we have a zoning. The atrium in the middle, it's difficult to see in this slide, but the zoning in the middle, you will have a different indoor climate than where the people actually sit and work. So in the middle, we allow temperatures from 18 to 28 degrees following the season, and where the offices are placed, we do not allow those big changes. So it's more about 20 to 22 degrees. So that's the overall indoor climate strategy. The next level is a user zoning. So you will have people sitting 12 persons together. They can control their own indoor environment. So if you have a group sitting working late, you can have your lights on and everything, but other people, when they leave, they can turn off. So you don't have to light up the whole thing. And then we have the facade design. In this case, it's a very, very classical type of facade with a horizontal window. And then we have put iron-free glass in the lower parts. In the middle, you have 3 layers of glass in the lower parts, and the middle one is iron-free. So it secures the quality of light is very high in this building, and it's very white. So it's not green. It doesn't color the whole building inside. And then we do optimize the building with LED fixtures inside the building, but are also outside in the park. And by this we hit the 42 kilowatt hours per square meter per year. And this client were not interested in becoming certified in any way. They were just interested in having a low consumption building. So the result is you halven the energy reduction, and you will also sense it in the way that the daylight is organized and you walk around. Then we have a more complex issue about microclimate, because this is when complexity rises. And this is a King Abdullah Financial District in Saudi Arabia. This is a render, a very early render. As I said before, it's about protecting the area in the middle, the green area, by organizing the volumes right, protecting the wadi. Some of the issues here is not only heat, summer heat, but it's also sandstorms. So it's very important that you you put up these buildings in the way so the wind will pass, be lifted over the whole area. And we did a lot of studies of this in the research. And here you see the solar gain on the buildings, and this is a relationship to the envelope and the design manual that we have done afterwards. Some of the issues here is that light-colored facade material can increase the daylight level with up to 20% in an area. And this is a very traditional way of increasing the amount of daylight quality. This is an example of this. This first picture is from Chicago, and the other one is from Wall Street in New York. And here you can clearly see the difference from a glass dominated facade type to a light-colored facade type. In the design manual of the King Abdullah Financial District, we work with the plots. So it's not about one skyscraper, it's about a relationship to the ground level. We want to ensure that people can have access to the outside, and the way that we meet the ground level doesn't create any problem with wind, locally downdraft, but also shading. So we came up with a lot of plot design, and you can say we did some of them ourselves. And this is called Villas in the Sky, and it has a small energy reduction. And these are some of the pictures from the area. And this is an image from the Wadi, and of course that's the last thing that they do, which is, I would say, in a European context, you would start with the most valuable, and then you will build out from there. But in Saudi Arabia, you just do it from the outside and in. Yes, I would say, finally, sustainability is a design parameter for us, and it's bringing in more meaningfulness and value in our lives and society, and it must drive a social change. Otherwise, I think it's actually a kind of greenwash. Thank you.
Thank you for your talk. That was very interesting and informative. Thank you. 네, 시네 콩브리스 디자인 위드 날리지라는 주제의 강연을 잘 들었습니다.